What is dark matter? Well, the surprising answer that not everybody likes to hear is that we're not exactly sure. But we have strong experimental evidence that lets us know that it's there and tells us about some of its properties. The first of these that I'll talk about today is the rotation of galaxies. And I'm going to give you a simple example to set some context here. Say you're observing our solar system from a different planet. You're looking down on it. There's this big mass in the center, the sun, and there are planets orbiting around it. And if you have an understanding of gravity, you know that it's the gravitational influence of this big body in the center of our star, the sun, that makes everything orbit around it. If the sun weren't there, each of these planets would fly off and go about their separate ways. Say now you observe a different system where there are many planets orbiting around a common center, but no big mass in the middle. Well, that's enough of a reason to be suspicious, right? There has to be something gravitationally here pulling everything together. And that's kind of what we see in galaxies. When observing distant galaxies, these rotate in a certain way, and after accounting for all the mass that we can see, these shouldn't be holding together and moving the way they are. Extra mass is needed that's not visible to hold things together. This is what we call dark matter. Now, dark matter is not really concentrated in the center of galaxies like in my example. It's more distributed in halos around it, but this extra mass is what's needed to explain these dynamics. To be fair, there are people proposing that maybe our understanding of gravity is not correct and dark matter is not really there. But these theories haven't really held up against experiment, at least this far. In subsequent videos, I'll give you other reasons why we know dark matter is there. So stay tuned. Thanks for watching.